Hello everyone, welcome back to Creative Civil Engineering Coach. In this session we will discuss about different types of plastic analysis theorems. The various type of plastic theorems depending upon which the plastic analysis have been developed are classified into following three types: lower bound theorem, upper bound theorem and uniqueness theorem. So all these theorems under the plastic analysis is based on working load and collapse load. We'll discuss one by one. The very first theorem is about lower bound theorem. It states that if the structure is assumed to be fully plastic and equilibrium is satisfied, the load calculated is less than or equal to true collapse load. Coming to upper bound theorem, this theorem states that if a collapse mechanism is assumed and the work equation is satisfied, the load calculated is greater than or equal to the true collapse load. Coming to uniqueness theorem, it is a combination of both lower bound theorem as well as upper bound theorem. So in this theorem, the calculated load is equal to the collapse load. W is equal to WC. This theorem also suggests about the condition of the true capacity. So here at the lower bound theorem, it is underestimated, and at upper bound theorem, it is overestimated, and at the uniqueness theorem, it gives the exact collapse load that lies between the bounds and it is unique. So now we will discuss about the lower bound theorem. Lower bound theorem is also called as static method. So it is a fundamental theorem in the plastic structure analysis that provides the safer lower limit to the true collapse load. Lower bound theorem states that if you can find a bending moment distribution that satisfies equilibrium and does not exceed the plastic moment capacity anywhere, then the calculated load is lesser than or equal to the true collapse load. So here it is represented by W lesser than or equal to WC, where W stands for calculated load by the static method and WC stands for true collapse load. Now coming to upper bound theorem, this theorem is also known as kinematic method, which is a very safe approach to estimate the collapse load. So coming to the definition of this theorem, the upper bound theorem states that if you assume a valid collapse mechanism, the load calculated by equating internal plastic work to external work, which is greater than or equal to the true collapse load. So according to this theorem, the assumed or calculated load is greater than or equal to collapse load. However, to determine the collapse load, the internal work done should be equated to external work done. Now we will look into the uniqueness theorem. Uniqueness theorem is found by combining the static and kinematic theorems. As we discussed earlier, it is a combination of both lower bound theorem and upper bound theorem. So this theorem, it is a very unique theorem which gives the unique value for the collapse load. According to this uniqueness theorem, by the static theorem, it is not possible to find a bending moment distribution which violates equilibrium or exceeds the allowable plastic moment at any section. By the kinematic theorem, it is not possible to establish any mechanism for which corresponding load is lesser than collapse load. And hence, when these two theorems are combined, they form a unique value of the load which is equal to the collapse load. According to this uniqueness theorem, the bending moment distribution which satisfies the following conditions are equal. So you can observe in this picture, both the combination of static theorem as well as the kinematic theorem is displayed, where the calculated load is equal to the collapse load.